Comparable to this area, okay, and this is comparable to this area, okay. Now I told you users will be using this, not this. Users, if suppose you are pouring water, you pour water here, but you don't pour water here in the bucket. I told you, right? When you have buckets, you are using 2 buckets. You pour water here now. After this scenario, no, you pour water there. If you do here, then you will corrupt the system. You can't access this. So if you have a dry pointer to this, you should not use it. You should use only this. Always you have to use only the meta device in the case of volume management in Solaris. In the case of Linux, you have to use the volumes in the volume group. In the case of Veritas, you have to use the volumes in the disk group. In the case of Veritas, the difference what you see here will be like this. Instead of MD, there will be VX in the case of Veritas. Okay? In the case of Linux, there will be group, volume group, right? Okay. And I also said, I don't have to use the entire hard drive. I can take a portion of the hard drive. That portion is called subdisk. Subdisk. So I can assemble pieces from different hard drives and make a volume, construct a volume.
In case you're using the whole hard drives, like 350 and 40, so you will still consider them as subdisk, or you do it differently?
We will. What is the question again?
Instead of using the subdisk, right, the slices of a disk, if you use the whole of it, like 3T and 40 entire, so how does it?
What's that?
The
It will be taking packages. Or depending on the technology we use.
But can we do that, or does it always have to
We can do that, but depending on the technology. Don't go into that detail. Right? Good evening.
Good night. Lost and found.
What about you, Chair?
He came with lunch for it.
Good night, sleep tight.
Even though he came careful, he came late, he is very careful.
Because he's up, awake.
Okay.
He just got up. So,
But you didn't lose anything.
But he
You
came
can
with
play
lunch
this
for it.
in that room, right? So I said I can take a portion of this, but this portion should be a continuous portion. I can't take a piece from here, and make a hard disk. Can I do like that? One piece from here, one piece? No, I can. It should be a continuous piece. Then I will take from 3 hard drives and then make it. What is the advantage of doing that? Because writing, reading, and writing will be fast. Because they are controlled by different controllers, maybe, right?
So the making that subdisk is, in order to that, we have to make sure that what is that going to be file server, or is that going to be a the store files, or is that going to be the save as what? If we consider it as a subdisk, right, we have to mention that as well. What is going to save in there? Is that going to be pictures, or is that going to be videos? Is that going to be?
It doesn't
file?
matter. Whatever you save there, it doesn't matter, right? For what you are saying, the size matters, right? If suppose,
In order to make it fast.
no, whether I save graphics or accounting files, it is going to be fast because it's made from 3 hard drives. It is going to be fast. But when you talk about graphics, I think you are talking about the size, file size, right? So when you are creating the file system, we can tune the file system in such a way the large files will get stored faster. That has nothing to do with this. Okay?
I have one more question, Don. So you are saying the subdisk has to be one slice, right?
Yeah.
Whole slice. So can it be one whole slice? So can you have 2 whole slice from one disk, or
Can you have what?
can you have 2 slices from a disk?
Yeah, why not?
So but then it becomes, so if you have slices, it becomes like a subdisk then,
Yeah.
right? Okay.
Well, if suppose you make two sub-disks here and using two from here, it's okay, no
Okay,
problem.
it's a disk.
First I said sub-disk, the advantage is the speed. Second advantage is you are not using the entire hard drive. I break the hard drive into small sub-disks and I just keep on adding as and when I want. Say if I have all these hard drives 5 terabytes and if I don't have sub-disk concept, then if I want to increase the, if I want to add another hard drive to this particular, if I'm adding hard drives to this volume, I have to add the full hard drive, right? Yeah.
But if in case you are having two sub-disks from the same disk, you are not achieving the
Yeah.
advantage of
But I'm
speed.
achieving something else. I'm
But
not
you're not
using the
getting the
entire hard
speed.
drive, I'm using portion by portion.
But you're not getting the speed advantage and
Yeah,
all those
of course.
advantages, right?
Yeah.
Because the controller is still one.
Yeah.
Only when you are using different drives, that's when you
That's
get
okay.
that advantage.
Okay?
Also, it's because of that using of controller that making this is faster.
Faster.
Yeah, because different controllers, the system is sending data through
Fast.
different paths, right?
Okay.
Sending or receiving data, right? Okay. So, so how these things work in different environments? I said almost all the operating systems have volume management. They are using some sort of volume management. If I take AX is one of the flavors of Unix. X, okay. X has built-in volume management. It has a built-in volume management. Veritas came from Veritas originally, right? Then HP Unix also has built-in, came from Veritas. So these commands, some maybe useful with some flavors, right? Some versions. Then we have Windows also, use Veritas. And then
Red Hat.
yeah, Red Hat also can use Veritas, but Red Hat also has now, even before they had volume management, right, built in, right? Yeah. So apart from that, apart from these Veritas related things, other ones have their own also, like Red Hat, Solaris has its own, and then what else?
SUSE.
SUSE has its own, SUSE is a volume volume group, right? Linux, all Linux have the volume group, right?
Debian.
Yeah, all of them. Solaris, what do they have? Solaris, what are the volume management? Solaris, what are the volume management? One is Solaris Volume Manager, other one is ZFS.
ZFS.
Red Hat, Logical Volume Manager, and also it can use Veritas, right? Solaris also can use Veritas, right? That's what you said, right? So, how will you achieve all these things? One, Ruben asked a question, can I just take a hard drive and put it there without any preparation? Just any hard drive, just. Okay, you are part of the disk group. Can I do that?
No.
In what environment? In what technology you cannot do?
In your Solaris.
IDE. SAT.
No. Technology, here, I'm
Oh,
talking about
technology.
technology here. In which technology you cannot do that?
Oh, in Veritas.
Yeah, so Veritas, I can't simply add a hard drive. So just adding a hard drive, in Veritas, no. What else? In what else I cannot just simply add a hard drive?
Where else?
Meta device also. Solaris,
Even
IBM.
Solaris you can't just
No,
add
Solaris
it.
you can.
Solaris you have to detect.
No, you can just add the hard drive. You don't
No
have to.
detection, no.
No, detection, operating system has to detect anyway, but after detecting you can just
Oh,
add.
okay.
But in Veritas, after detecting you can't just add, right? Veritas and what else? In Linux
IBM.
also. Linux.
IBM also you cannot put it.
Yeah, IBM now Veritas based, right? So Linux also, you can't just add. You have to convert them to physical volumes.
Physical
right?
value then.
Yeah,
Yeah.
physical volumes, and then only you can add. And Veritas also, you have to
Become part of the
you have to convert them to
Disk group.
vertical.
no. You have to before making this group, you have to convert them to Veritas understandable format. Veritas understandable format. How many slices it has? A regular hard drive.
8.
8.
Yeah, in this case 8.
So that will
Veritas
be-
understandable form will have how many slices?
4.
Only 2. So Veritas understandable hard drive, if I convert, that will have only 2 slices. One is public
Oh, yeah.
and other one is private.
Private.
In the case of Veritas. So I can't just take a hard drive and put it in Veritas disk group. I have to make it so that it will have public region and private region and then put it in Veritas. Right? In the case of Linux, you make physical volumes, right? Okay? PV create, Linux will use PV create to create a physical volume. So here we use some commands, we will come to that. In Solaris, all the commands which are used to work in Solaris Volume Manager, all the commands which are used for Solaris Volume Manager start with
Meta.
meta. So if you go and check in the computer, the commands starting with meta, those are the commands. Meta db, meta create, right? Meta db, meta create, meta attach, meta detach, right? All meta, right?
Meta device.
So easy. If you're in a graphics, if you're clicking, you can't remember so many things in one shot. Here, meta all the commands. I can list, then I can go to the help page of all the commands, how to use it. Very easy. I don't have to keep anything in the head, right? So you understand the concept here, right? So if I say meta, you will see all the commands. Then you find out help on each command, how to use it, right? And what is the procedure to use. That's all you have to know, right? Yeah. In the case of Linux,
PX. Oh, sorry.
if I want to talk about physical volumes, it will start with PV. PV, physical volume. So all the commands starting with PV, PV create, right, like that, PV. All the commands starting with, all the commands managing groups will start with
GB.
LG.
VG.
Or VG,
VG, yeah.
VG, VG, right? And all the commands starting with what these volumes? Create volume and all.
CV. Logical volume, LG.
LV.
LV.
LV, like that. So they have a pattern, so you don't have to memorize. Don't worry about that now, right? I'm just telling this is easy. Commands are easier because you don't have to memorize. Don't think commands you have to memorize. No, it's there in the system. So you go and just type LV and show all the commands starting with LV. It will show. We'll learn how to do it, right? So that is also fine. So in the case of Veritas, all the commands start with what?
DG.
Veritas.
VG, right?
DG.
No, VX.
Okay.
You said
VX.
VX.
No, no. Yeah. In Linux we said PV, VG, LV.
Yeah.
In Veritas,
VX.
DG.
Veritas should be VX.
only VX.
Huh?
Only VX.
Only
Yeah, that's
VX. That's what I said.
So you don't say PVG, no. All the commands starting with VX. Those are the commands we use for any purpose. So that is easier than this in that way. But these commands are easier. Linux, PV, create, all very like English, right? But here all the commands start with VX. If you go and list all the commands starting with VX, then you will see all of them.
Daemon starts with VX too.
Pardon?
Daemon starts with
The
VX
background
too.
process.
Daemon. Yeah.
Why
VX config D.
How about zombie?
Yeah, daemons for the this one.
Yeah.
So everything in that environment start with VX. Okay? What is the data transfer? Okay. If you want to set up a disk, what is the command? Disk setup, what is the command?
Yes.
You want to set up a disk, Veritas disk setup, what is the command?
VXDS.
VX disk
Disk setup.
setup. You know the command. Okay? So VX disk setup. That is the command you have to use. So I bought a brand new hard drive. This is a new hard drive. So can I add that in this volume group? In the disk group?
Yeah.
Yes, sir.
No. I have to first convert to
Convert to
You
physical.
do.
Two regions.
Physical.
Two regions.
two
private
regions,
and
Yeah.
public and private. So for that the command is VS disk setup. Or VX disk setup. One command. Right?